Hello YouTube. Sorry for a long time not posting video for you guys. I hope my previous tutorials can help you in some ways. If you follow my tutorials and don't get results or the program does not work correctly, don't be frustrated. I must say building Android application is not easy. Since Android gives you a lot of flexibilities, it also comes with very strange problems. If you still want to handle it, just give it a try more. Ask Google about your problem. You will master it. So today in this tutorial, I'll show you how to make an Android Vision application using Google Vision API for the face and the landmark detection. So using Google Vision API has some advantages and disadvantages. The advantages is it can help you make application very quickly without knowing about the native library, the JNI function, because Google has done it for you. But the disadvantages is it is not flexible. Google Vision API gives you a function for the face and landmark detection or text recognition. But in case if you want to recognize the text from the native language instead of English, this function will not work. So you should go with the OpenCV and build the library by yourself. Okay, so let's get started. First, create a new project. Create a new project and call that is a photo demo. Hit next, next, and next. The main activity and finish. So working with the Google Vision API, you do not need to care about the native part. Just do programming in the Java environment. Okay, and let me stop this program. And for this application, we need to have an image. I download this type image from the internet and call that is a group people image. Just copy and paste. Switch to the project. Go to the app, src, main, and res. In here in the res folder, create a new directory called raw folder and paste the image here. Okay, and then in the view Gradle, just add compile equal to com.google.android.smgms colon play dash services dash vision colon 909.4.0 and in the Android manifest. After the application, we need to add the metadata. Android name equal to com.android.gms.vision dependencies. And Android dot value is equal to face. Okay. Then and let's switch to the main activity and do a little programming here. Just let's make a string for displaying a log information. Private static string final string tag equal to main activity. Okay, and we need to get the image content from the raw folder. So input stream equal to input stream get resource open raw resource and r.raw.group people, and then we create a bitmap from the input stream. Bitmap factory dot decode stream and transfer the input stream there. Okay, now we need to create a face detector instance. Face detector instance. Okay, so if you see in here, face detector just has the Android media and the Android.hardware.camera. So that is not correct. You need to build the project again in order to make your program download the native private static could not find .com Android GMS Play services vision. So we need to check again here, vision. I'm missing I in here, so we need to build it again to make the Android Studio download the native library for you. So make sure that you have the internet connection during doing this project. Okay, just put this line here and build it again. Okay, let's try it. Face detector. You do not see the face detector from the Google API yet, so you should go to synchronize the project with the Gradle file. Okay, let's see face detector. So you see here face detector from com.google.android.gms. So we have detector and new equal to new face detector dot builder and we get the get application context and then set the landmark type is a face detector all landmarks and set tracking enable is false since we are working with the image instead of the video, and set mode face detector not fast mode and build. Okay, so the face detector, in order to run the detector from the Google Vision API, you should convert the bitmap to the frame equal to new frame dot builder set dot set frame set bitmap and bitmap dot build. Okay, so if you check in here in the import, it already automatically import for you the vision.frame from the Google Vision API, and we need to make a array to store the face result from the detector called the spare array and face, we call that is faces detector dot detect and transfer the frame that we obtain. Okay, we need to import the class for faces. Make sure that you have import it from the Google Vision API, and after that we need to check if the detector is optional. That means when you run the program for the first time, it needs to download the native library. So if the native library is missing in your computer, the detector will not detect any face. So will show if it is has no native library. We show the information tag face detector dependencies. Face detector dependencies is not available. Okay. And return. So now we have the face is detected. We want to display the result onto the image and display that image on the screen of the image, screen of the device. So we need to have a view. So I will create a custom view for doing that. New Java class and call that is my view. Okay, and okay, and in the my view.java we need to extend the view class. In the view class we have some private spare array, face, mface. Mface and also the private bitmap. Bitmap and bitmap. Okay. And just write the constructor for this class and public my view content context attribute set attrs and call the function from the super context and attrs. And we create a function for set a content of this class. Set content bitmap. Bitmap sparse. We transfer the bitmap and the spare array that store the face we just detected, and mbitmap is equal to bitmap, mface is equal to faces. Okay, and make it and update it in validate. Okay, and in this function, in this class, you do not need to override all the method, but one on draw method, the most important one, decide the behavior of the class. So we override on draw. Oh. And inside, after the super on draw canvas, will check if the bitmap is not equal to null. And faces we need to have is not equal to null. Then we get the view width from the canvas, and get the view height from the canvas. Also the image width from the image from the bitmap. Image height and bitmap dot get height. And decide the scale, which is the minimum scale from the ratio of the view width and the image width, and view height and image height. View width divide by image width, or view height image height. And we make a rectangle destination about equal to new rectangle of 0, 0, int image height multiply by scale, and int image width multiply by scale. Okay, just add some dependencies for rectangle. Now we are trying to draw a bitmap to canvas. Canvas dot draw canvas dot draw bitmap, and transfer our bitmap null destination bound and null. We need to create a pane instant. Call this pane is equal to new pane. Add pane and set the property for pane. For the object pane, set color equal to, let's say, green. Okay, dot set style, paint style dot stroke, and paint set stroke width is equal to 4, and we loop for all the faces detected. E equal to 0, E smaller than M face dot size, and E plus plus, and we get the face from the faces. M face get value at eye position, that we have the eye face, and from the eye face we get the X position, int face get position dot x, int y, int face dot get position dot y, and the width of the rectangle int face dot get width plus x, int height, int face get height plus y, and we draw a rectangle on the canvas. Draw rectangle, X position, Y position, width and height, and the paint object. Okay, and now if you want to draw a landmark on that face, we need to have another loop inside the face, inside each face. Landmark, we have landmark from the face dot get landmark, and for each landmark we have cx equal to int landmark get position dot x multiply by scale, int cy equal to int landmark get position y multiply by scale. Okay, so in here in the rectangle we also need to multiply to the scale. and here okay, and just just call the view in here, okay. So let's switch to the layout, and in the activity main, delete this one, okay. Just com dot example my view and android dot id equal to id my view, wrap content and delete the hello world, okay. And here instead of grab content we have parent match, and here parent match, okay. Switch to the main activity.java and binding the face the view from the layout and the Java code. My view is my view equal to my view by view by id r dot id dot what my view, okay. And my view we call the set content and transfer here the bitmap and the faces, the list of the face. We just want to draw a rectangle, and after that we need to release the detector for free the resource, okay. Let's build it. That's it. Let's build it. Let's build it and port it to the Android. Here I have the S7 device, S7 or S6, I don't remember. Let's see. Hello. Okay, and let me open the Miro MP. Miro MP.receiver. And open the Miro MP dot for sender. Okay, so I have Miro MP. It's a little bit slow. Okay, so let's build the application. I have this device and I select it. Let's wait a little, a few minutes. Where is my Miro MP? Where is my Miro MP? Here. Okay. Let's see if it can run. It's very simple and very useful if the Google Vision API can give us some functionality. Okay. Okay, so if you see in here, the rectangle is outside of the image. I know what happened. Let me see. Where we draw a rectangle, scale, mean, scale, int, destination bound. We multiply the scale 2 times. That's very funny. That is my fault. Okay, we multiply the position in here and in here. That's correct. Let's run it again. Let's see the Miro OP. Oh my god. So here we need to go back. We need to multiply by scale here. That is correct. But first we need to specify the width, not the height. Width here and height here. And then we have the width and the height here. Okay, I hope now it can work correctly. And the last thing here, if you want to see the canvas for the landmark detection, if you want to display the landmark detection on the image, we need to draw it. Canvas, draw a circle, CX, CY, and let's say 5, radius is 5, and call the pane, CX and CY. See here. Okay. So let's run it again. Is because Google, they already optimize the Vision API, so it runs very quickly. Restart the app. Okay. So okay, so in here when we get the face width, we also need to multiply by the scale and multiply by scale and plus the position. Okay, so let's run it again. Mirror OP. Mirror OP. Select the mirror OP. Play. What's wrong with my mirror OP? It cannot connect. Okay, let me turn it off and run it again. It's searching for the receiver. Select the receiver. Play. Okay. Play. Play. Project and time connection may be interrupt. Home. Okay, so my device and the mirror OP already get connected. Let's run the program again. So you see here the landmark detection and the face detection. In this API, Vision API, it gives only 1, 2, 3, 4. It gives only 8 landmarks points instead of 68 landmark point in the Dellipse. That's it. Thank you for watching.